Hello students, welcome to RD Chemistry. If you are not yet subscribed RD Chemistry, please do subscribe, like the videos, share the videos and please comment. In this video, I am going to explain mechanisms of nucleophilic substitution reaction. In the previous video, I had explained the various types of nucleophilic substitution reactions. Basically, there are two types of mechanisms under nucleophilic substitution reactions. When I say nucleophilic substitution reaction, it is written as the symbol S. S stands for substitution. And it is carried out by nucleophile. Therefore, we write SN, capital letter N as the suffix. Now, there are two types of SN reaction. SN stands for substitution carried out by nucleophile. They are SN1 mechanism and second one is the SN2 mechanism. Okay. S stands for substitution, nucleophilic, nucleophilic. 1 stands for unimolecular. Unimolecular means involves one molecule. SN2 stands for substitution, nucleophilic. 2 stands for bimolecular. Bimolecular means two molecules are involved. Now, when I say unimolecular and bimolecular, they are involved in the slowest step according to chemical kinetics concept. So now I'm going to explain the SN2 mechanism first. There's a reason why I'm going to take SN2 first, then I'll be taking SN1 later. Okay. So let me explain SN2 mechanism. So let me take one example for SN2 mechanism of the reaction. The example would be, so alkaline hydrolysis of methyl chloride to give methyl alcohol. Now what is the meaning of alkaline hydrolysis? When I say hydrolysis, water should be there. When I say alkaline is like a base. What is a base? Base like a sodium hydroxide dissolved in water. Now what is the actual nucleophile here? So there are two nucleophiles actually, OH minus and water. Water is a neutral nucleophile. OH minus is a stronger nucleophile. Okay. So water is a stronger nucleophile. We can't take simply hydroxide. Sodium hydroxide is a solid. It should be dissolved in water. That's why we call it the alkaline hydrolysis, or it is aqueous solution. Okay. So aqueous solution of sodium hydroxide. So actually which one is the nucleophile? Stronger nucleophile is the hydroxide ion, and what is the neutral nucleophile, which is the weaker nucleophile compared to hydroxide. So we'll be writing reaction with respect to now hydroxide. So let me write methyl chloride. Methyl chloride reacts with the sodium hydroxide. Okay, so I'll write only hydroxide here. So what do you mean by nucleophilic substitution reaction? This chlorine atom should be replaced by OH minus. So we'll get CH3 OH plus Cl minus goes out. Even Cl minus is also a nucleophile, but is a weaker nucleophile compared to hydroxide. That's why the reaction takes place. Cl minus replaced by the OH minus. Or I can write CH3Cl reacts with the actual NaOH aqueous solution, correct, to give methyl alcohol plus sodium chloride. This is the actual reaction, but we are written only in terms of nucleophile. For this reaction, we are going to learn the mechanism, how actually the reaction taking place. Okay, clear? So here we are going to make use of methyl chloride, correct? Methyl chloride here, correct? Methyl chloride. Carbon atom attached to the hydrogen 1, second hydrogen, third hydrogen, and next one the chlorine. Okay, this carbon atom is a sp3 hybridized. If it is so, its geometry should be tetrahedral geometry, correct? Bond angle should be 109.5 degrees, correct? And we are going to make the hydroxide OH minus, correct? So I am going to write now two-dimensional structure for methyl chloride. Carbon attached to the chlorine. Then hydrogen 1, 2, 3 hydrogen. Okay. So I'm not going to write three-dimensional shape. I'm going to write two-dimensional shape here. Okay. So 2D shape it is. It reacts with the hydroxide OH minus. So OH minus should attack the carbon atom. Correct. This carbon should attack. Then chlorine should go out. Now see here. OH minus cannot attack from the carbon atom from the same side as that of the chlorine atom here. Why? Because chlorine, the atomic mass is 35.5. OH minus atom mass is oxygen is 16, hydrogen is 1, so 17, correct? So what will happen? This Cl is a bulkier when compared to hydrogen here. Hydrogen atom mass is 1, correct? Therefore, hydroxide nucleophile tries to attack the carbon atom from the weaker side. So it attack from the back side. So it is called the backside attack. It cannot come from the same side as that of the chlorine because chlorine little bulkier. So OH minus always go to that side where there is no bulkiness is not there. Okay, so hindrance should not be there. So it is attacked from the back side. To give, now what will happen? This carbon chlorine bond is a sigma bond, covalent bond. It is a stronger bond, cannot be broken very easily. Therefore, attack is always very slow step. Okay, very slow step. Also called as the RDS. RDS stand for rate determining step. This is going to study in the chemical kinetics. So rate determining step it is. It is known as the rate determining step. Clear? Rate determining step. Clear it is? So OH minus attack the carbon atom from the side opposite to that of the chlorine atom. From the less hindered side. Okay? From the weaker side. Clear? Got it? Now, in this case, there is a transition state form. There is an intermediate form. What is transition state? That means carbon is attached to the chlorine. Carbon-chlorine bond will break slowly. So, I'll write dotted lines. Partial bond breaking. Also, new bond is formed between carbon and the hydroxide group, OH group. Correct? So, dotted line represent partial bond making and partial bond breaking. Where are those hydrogens? 3 hydrogen. They will be in the same plane. Hydrogen, hydrogen and hydrogen. These 3 hydrogen, they will form triangular shape. Okay. And OH minus and Cl minus are opposite sides of the triangle. Got it? So, this transit state we are going to write within the square brackets. Now see here, the carbon attached to the 5 groups here. There are altogether 5 groups, correct? That means valence is 5. Therefore, this is a very unstable transition state. Carbon generally should be attached to how many bonds? 4 bonds. Then only it is stable. Now it is unstable. Therefore, this transition state is highly unstable, easily decomposes. So it decomposes to give. Okay. So OH now will form permanent bond with the carbon atom. And hydrogens will go on the opposite side when compared to the initial molecule, that is the methyl chloride, this one. Why? Because OH group net little bulkier now. Hydrogens will go on the other side. And then we'll have the Cl minus coming out, which is known as the leaving group. Correct? Now, this is a very unstable transition state. Should be easily decomposer. That means this is a very fast step. Okay, so it's a very fast step. So initially we have got a very slow step, which is a rate determining step, and after the forming the unstable transition, decomp will become easier and the fastest step. Clear? So I'll repeat again. The nucleophile OH minus attack the carbon atom opposite to that of the chlorine atom to form the unstable transition state where there is a partial bond making and partial bond breaking. This unstable transit state easily decomposes to give the final product. So we get here methyl alcohol. Methyl alcohol. Correct? Remember here, backside attack takes place. Clear? Now here, rate of the reaction depends on the slow step. Rate of the reaction depends on the slow step. Correct? Slow step. In the slow step, how many molecules are there? There are two molecules, right? One is the methyl chloride and the one is the hydroxide, that's the nucleophile. Correct? So according to chemical kinetics, we write rate is equal to one constant K into, there are two molecule, reactant molecule, concentration reactant molecule. One is the methyl chloride, one molecule, other one is the hydroxide group, only one here. So therefore, order of this reaction is, okay, add the powers of the concentration terms, 1 plus 1. Therefore, order is equal to 2. Since order is equal to 2, we call it as the bimolecular reaction. Bimolecular reaction. That's why we have the, okay, notation SN2. S stand for substitution, N stand for nucleophilic, and 2 stand for the bimolecular reaction, because there are two molecules involved. One is the methyl chloride, other one is the hydroxide ion. Two molecules. Clear? Right? Now see here, Cl is there, was there on the right hand side. The new nucleophile comes and attacks on the opposite side. It goes on the left hand side. So what will happen now? This process is called the inversion process. Okay. So inversion takes place during the SN2 mechanism. Remember, during SN2 mechanism, inversion takes place. Clear? Now we have got three types of alkyl halide, correct? Primary alkyl halide, secondary alkyl halide, and tertiary alkyl halide. Also, we have got one more type, methyl halide, simplest halide, which will react fastest toward the SN2 reaction. It is the methyl halide, CH3X. Okay, methyl halide is very reactive towards nucleophilic substitution reaction. Then comes primary alkyl halide, then comes secondary alkyl halide, then comes the tertiary alkyl halide. Tertiary alkyl, when I say it is a bulkier, whenever bulkier alkyl halides are there, does not undergo SN2 mechanism, instead it undergoes SN1 mechanism. So this is the order of reactivity of the alkyl halide towards SN2 mechanism. Okay, so I'll call it as the SN2 reactivity. Got it? Right? In this video, we have learnt SN2 mechanism. In the next video, I will explain SN1 mechanism. Like the videos, share the videos, and please do subscribe RD Chemistry, and also write down the comments. Thank you for watching.